Okay, should we get started?
Yeah, I think we can.
It's 10:01. Perfect. Thank you, everybody, for being a part of this session today. We call this session Gen AI System Design. Again, if you're coming from a computer science background, you already know what system design is. If you're not, it's just as simple as how do you design generative AI systems, right? Just a heads up that this session will go from 0 to 1 very quickly. So I just request that you don't multitask or do other things on the side. It'll seem like, oh, I know this, but then it will get into full power pretty soon. If you want to turn on your video, if that is your forcing function, please go ahead and do it. But then please pay full attention. I'm sure you'll get a lot of value from this session. Just to get started, right? Like, what were AI systems from, say, before 2010 to now? There has been a lot of change in what we think of AI. Before 2010, there was not a really solid definition of AI, and not really AI systems that were available, right? We were pretty much dealing with traditional programming kind of systems, which had some form of rule-based automation, if-then logics, decision trees, etc., right? And these were pretty much hard-coded workflows. In late 2010s, we entered this era of what we call as predictive AI, where people started understanding that instead of writing these if-then conditions or decision trees, we can feed in a lot of data to these machine learning models, and they learn patterns from that data to make predictions, right? But most of these predictions were still somewhat limited in nature, which means that the kind of tasks that enterprises would take on, in late 2010s or even early 2010s, is just things like sentiment analysis, is this positive or negative, fraud detection, stock prediction, all of this. So if you see the outputs here, it's pretty limited in nature. But today we're talking about generative AI, where the process is somewhat the same at the high level, but then the kind of outputs you see are much different. They have so much more scope, right? Things like generating words, generating images, generating even actions as in, all of this anthropic computer use or operator, all of these basically generate web actions. So if you see the amount of output, or the diversity in output, has increased significantly just going from traditional programming to Gen AI, right? And if that still isn't convincing enough, this is a very simple use case. If we have something like, does the image represent a cat or a dog? What traditional programming would do is basically write a bunch of conditions, right? If this image has whiskers, or if the ear shape is pointy, then you would say cat, otherwise return dog, and things like that. In predictive AI, you would basically feed in all of this information to machine learning models, and it would use patterns to make these distinctions. And still, it would predict a class like dog or cat or whatever. But today in generative AI, you pretty much use transformer-based models or related models, and now you have more of a very, long sentence that kind of gives you much more information. It's not just a class; it's basically a bunch of different words coming from a huge distribution of vocabulary, right? So that's basically how we've kind of moved for the same task at hand. Now, if you kind of look at this in a very determinism perspective, like how deterministic is your system, you will see that going from traditional programming to generative AI, the input somewhat remains pretty much the same. The processes have changed, where traditional programming is very deterministic, predictive AI is more of learning patterns, generative AI is also learning patterns, but the output is what has changed significantly, right? For traditional programming, you always have a fixed set of outputs, and it's very deterministic. In predictive AI, you basically have fixed length classes like positive, negative class, or dog or cat class, or even numerical values, right? Some numbers around predictions. But for generative AI, you can have variable length words, you can have actions, you can have a wide array of outputs. So if you kind of put it on a determinism framework, there is max determinism in traditional programming as compared to minimum determinism in generative AI. Now, why I'm talking about this is because non-deterministic outputs are basically an enterprise's biggest headache. If a bunch of you have worked in businesses, you know for a fact that determinism is pretty important. Robustness is pretty important in enterprises, right? I'm pretty sure enterprises are not asking, does the image represent a cat or a dog? But even for a question as simple as this, if you probably use different GenAI systems, different AI models today, you'll probably get hundreds of different answers, right? These are just 5 of them. Now, depending on what this result is used for, where it is used in the pipeline or in the workflow for an enterprise system, you will basically have to choose different answers. So there's so much of context in the enterprise itself, which makes non-determinism a little painful, right? And that's just to kind of give you motivation why Gen AI systems or why designing them is a little harder. Now, to add to this non-determinism that they also bring a set of new issues that we have never seen in previous systems, right? Most of you have already heard this, but just a very small gist of what the common issues are. Hallucinations, which is producing, false or misleading information. Sycophancy, which is if people come with their inherent biases and talk to AI systems, then AI generally tends to support us as compared to, supporting factual correctness. Then inconsistent response lengths, you're not really sure how many words this system will generate. Prompt sensitivity, which is basically just change 2 or 3 words in your prompts and the answer completely changes. It reinforces biases. Lower explainability, because these models are kind of huge and we don't really know what are the switches that are going off in order to give us certain responses. High latency again, because as compared to previous machine learning models, these are pretty huge, right? And they take much longer time. These are just a few of the top differences, which necessitates us to have completely different idea of what Gen AI system design is as compared to traditional programming or compared to machine learning, right? Or more of predictive AI. So that kind of brings us to this understanding that designing generative AI systems is kind of hard. If it's not hard, it's basically different. So you really need a different approach in order to do it. At this point, you're probably thinking like, okay, fine, I know it's hard, but what is the value that lies in this system, right? Why do we even need to build Gen AI systems? I know most of you know the value, but just to kind of rub it in your face, I guess, the the one baseline I want to kind of introduce over here is most people, when they talk about Gen AI, think that the real breakthrough in Gen AI lies in the generation, right? We are able to generate something that we're not able to generate before. But really, the biggest breakthrough for us in Gen AI is not generation, it's zero shot natural language understanding. Now, what that means is previously, when you're looking at machine learning systems, you couldn't interact with them in a human way, right? They wouldn't understand human language very easily. And they were more of narrow AI, which means that even to do a task like sentiment analysis, you have to kind of put in a ton of data, train these models, and then they would predict classes. They would never generalize to different tasks without, explicitly training for that task. So our entire mindset with Gen AI kind of changed from how do you want to train your system to do a task X to how do you want to talk to your system to do a task X, right? It entirely changed our perspective of just talking to a pipeline in order to, or, typing or providing natural language instructions to a pipeline in order to complete a task, as opposed to, training it or going through this entire process of, creating these models for specific tasks. And that makes a world of a difference, right? So the baseline that you should always remember is the real breakthrough in Gen AI is just, it is generation, obviously, but it's also just how much better understanding became, natural language understanding became, right? So to kind of summarize it, today's Gen AI can be pretty much take in any different modality of data, whether it's your documents, it's your structured databases, images, videos, etc., and also produce all of this, right? Text, videos, images, or even actions and stuff like that. So pretty much all of these tasks can be kind of fit into the Gen AI structure. Obviously, it does perform well in some, and for some, you need to, improve its performance, or you need to get it close to what your whatever your expectation is. But basically, it opens up this new world for us. So what you're like, okay, fine, this is a very good understanding. I feel like I understand what Gen AI does. And if you kind of had to put it in one statement, any task that requires knowledge comprehension, reasoning, generation, or action can basically use Gen AI. Now, if you kind of went a little deeper, think of tasks like customer support, right? Previously, you had to build these task-driven chat systems, which had to do with some amount of training and also some amount of rule based in order to create a chat customer support system. But now you can have AI that adapts responses dynamically. Think of a healthcare kind of a setting, right? You can summarize clinical notes, medical literature, etc., and all of this by you can get some decent amount of performance even without training a system to do this, because it understands natural language. And then typical use cases like enterprise knowledge management itself, which is a huge pain for enterprises because knowledge is kind of scattered in different pockets. And then you can have AI that can understand this knowledge, generate policies, reports, and all of these things, right? I'm just sticking to 3 use cases. Of course, there are tons of different use cases and tons of different way where you can make use of this powerful capability of knowledge comprehension for Gen AI, right? So now we come to this understanding that, okay, designing Gen AI systems is hard, it's different, but at least it's valuable because it opens up so many different options for us, right? Now I'll let Kiriti take over and kind of go through how we go about designing this, right? You're on mute, Kiriti.
Every time. Okay, thank you. Yeah, just to summarize what Aishwarya mentioned, there are these like crucial sectors and crucial problems that Gen AI can solve. And say if you were to like start working on like one of this, what is something that comes to your mind? Now, if you're like following the recent hype train, yeah, this is what you would say. Just use AI agents. We strongly oppose this notion because it's not that agents are not powerful or not useful. It's just that you need to know the right time to use it and the right problem to give it to solve. So just slapping the AI agent label on top of every problem you encounter is not the way that we want to proceed. And that's the main intention of the course, is to make you understand the different building blocks that come in a Gen AI system and how you can leverage this information to actually build the system that solves the problem effectively, and hence the problem first approach. Next slide. So yeah, to recap what Aishwarya was saying, the main innovation of Gen AI is not about training your model, but being able to talk to it. So the AI component here, you can think of it as like a generalized model that has been trained, say like ChatGPT, Claude, on like a lot of like English text data and like multi-modality data, which responds to a more or less similar way to everybody based on their prompts. So the main innovation to actually challenge and like solve all these applications come from the application layer. So the application layer is what we'll define as like the way you can talk to the AI to actually let it know your problem and what your expectation is and help it to answer your questions effectively. So we will be like demonstrating basically 4 basic building blocks of Gen AI systems, and all the innovation comes in the application layer, as you'll see later. Next slide. Yeah, I think the first one and probably the most basic and like the most well-known one is prompting. Prompting is basically crafting your input in a certain way to essentially like solve your use case. For example, like if you want to summarize like a large paragraph of text, you will say like, please summarize this text, and then you'll post it later. And then you can actually add some important details on how you want the response to be, and like you can add that to the prompt and send it to the AI. So this is the most basic way everybody interacts with an AI. Like example, ChatGPT web interface, or like Claude web interface, and especially like this is useful when like the application layer can actually do some sort of post and pre-processing, where you know the actual context of the application that you're trying to solve, and then the pre and post processing can like be tuned to your use case. For example, if you want to produce like children's stories, you can add like such kind of information in the pre-processing prompt so that the user of the system doesn't need to always add those kind of things. So prompting is like the most basic approach of like building a Gen AI system, and you only proceed further if like this is not solving your use case. Let's take it a step further. I think most of you might have heard RAG, but just for the sake of keeping everyone on the same page, let's define what RAG is. RAG is essentially retrieval augmented generation. So let's break it down each of them. So retrieval is, instead of like having a static prompt, you're retrieving the relevant information from the knowledge sources that you have made available to the application. And augmented is essentially you're augmenting the prompt with the retrieval with the retrieved parts and like feeding it to the application layer, which in turn helps with the generation. So how is it different from prompting? Prompting is where you use a set of basic or static prompts where everything is static and like you feed in like dynamic part of the information. Whereas in RAG, you get the question and then you analyze a lot of your knowledge sources and then like identify the chunks of data that are actually relevant to this question and add it to the prompt. Now you can say, why do we need this? Like, can we not all append the entire knowledge source we have the prompts? The issue is that prompts are generally like limited in length. LLMs don't have like infinite. I mean, technically don't have like a lot of infinite context that you can just give everything and the information might get lost. So the RAG helps in like understanding what is the information that is important and feeding it to the model. Let's take it a next step further. And this is the fan favorite, I guess, agents. So you can see that how we are building step by step into like blocks of where the application layer gets more and more complex and at the same time more and more powerful. So agents, you can think of it as a framework where the application layer now is taken over by AI. And the reason we have like two AIs here is you can tune each of the base AI model and the application layer AI model like independently. So in this architecture, your application layer becomes more and more complex, powerful, and has the ability to actually use multiple types of tools. So it's no longer looking at chunks of text or like pieces of audio or something from your knowledge sources. It can actually access your databases if you teach it how to. It can like run queries, get the required information. It can use tools like Aishwarya mentioned, like the computer use, for example, is one of the tool where you're using a browser, or you can actually call REST APIs and like get the relevant information. So you can think of like in reducing a lot of functionality, but at the same time, a lot of complexity into the application layer. And that's how the agents can solve like more complex problems that the first two design problems could not have in certain use cases. So for example, if you go back to the previous slide of RAG, yeah. So if you're in a company and you just joined the company and you want to find out how many holidays does my company have per year. So what RAG would do is like go through the company's documentation and understand, oh, these are the holidays. Let's say you have like 10 holidays per year, and that will return to you as a response. But if you ask this system, how many holidays do I have left? Then it becomes a personalized question, and that information it's not any trivial knowledge sources. And if you go to the next slide, uh, application layer can actually solve, agents can actually solve this based on how you can get this information from different databases and like answer your question. To go to the next one, fine tuning. Yeah, so fine tuning is where actually you can keep the application layer, but actually train your model to adapt to your domain. What I mean by adapting to your domain is like, say, if you're building for legal or healthcare domain, there are certain kind of complexity terms or like the style of documents that you might want the AI to like produce, which the actually generalized trained AI could not do that. So in those cases, you actually approach like a fine tuning model. Next slide. Yeah, so to summarize, these are the only four blocks that you'll ever need to actually build a Gen AI system, which is like prompting, RAG, agents, and fine tuning. Now, you could say, Kiriti, there are like a lot of things that I've heard, like this, like multi-model RAG, agentic RAG, multi-agents, and stuff like that. What are they? So, what we strongly argue is that all of those are a combination of things that the four basic building blocks can actually like combine and give you. For example, if you take RAG and agents. You can get agentic RAG where you're not doing RAG just once, but an agent is controlling how the flow should look like, and like you can do RAG like multiple times dynamically. And similarly, if you can put together multiple agents together and build a multi-agent system, which is actually specific for like each domain and much might give you like much better performance. So and we can do this all day, like combining things and like getting a new system. But what the point we want to take home and what we enforce in this course is how you focus on the use case and drive the decision on understanding which blocks to use when. So basically prioritize the problem before thinking what fancy solution can I implement to solve the problem. So Aishwarya now will take you through the process of like how to do this, and we put together all our experience working in the industry to understand how basically this process works and like how we develop this mental model.
Thanks, Kiriti. So yes, stay with us. You will still need just these four different building blocks, and we will walk you through a solution to just tell you why whatever we're saying makes sense, right? Again, if you're going to be someone following our methodologies, then please prioritize the problem before the solution. We'll kind of show you that in action. So pretty much designing generative AI systems has all of these building blocks, right? I'll quickly walk through them. Each of them is a problem in itself to solve, but I'll kind of give you a very high level knowledge to do that, right? You first identify your use case, you curate data, then you choose the kind of application, basically the four different applications that we're talking about, then set up your extra knowledge or tools regarding, I mean, with respect to whatever application you choose, then you go about designing the application, curate your evaluation data, design evaluation metrics, and then you have bam, the final application. You're like, wow, this sounds amazing. Like I have a bunch of different steps to go around, right? But the real problem is that this is not the end of your solution. The biggest part or the most important part of designing AI applications is to identify gaps in your first solution and kind of optimize it, right? And that's where most of the magic happens. Most of the solutions that are designed follow an iterative solution pattern. You basically keep doing this over and over again until you get to the solution that gives you the best performance, right? So you're like, okay, now that makes sense, but I really don't know how I'll apply it to a real use case, right? So let's take a use case, a very popular one, and I'll tell you why our system works, right? So think of a business problem like design an AI-powered employee chatbot that enables employees to inquire about company documentation, HR policies, etc. Pretty much have like a search system for your company where instead of searching all of these thousands of documents, getting answers, you just chat and get answers. And this is basically a very simple RAG kind of a use case where basically you get information from documents, add it as context to the LLM and ask questions, right? Now, again, like if you're still not following what we're saying and you're like, we just use AI agents, what are you doing? Maybe take a pause. We'll explain. We will use AI agents, but we'll tell you when. So basically, the building blocks that I told you is to one, define the scope. A common mistake that people do is do not narrow down to 2-3 features. They do everything everywhere all at once, and we urge you not to do that. Pick a few features that you want to first implement, typical software engineering kind of best practices, right? And then curate data for that. What are the kind of questions employees might ask? What are the plausible answers for those, right? And then you go about choosing the model and the application. For model choosing, we have a specific framework that we have developed, which is basically performance, cost, and latency trade-off. I won't go too deep into it, but kind of gives you an idea of how to do it. It'll be covered much deeper in our course. And then you think, what is the simplest design that can solve my problem? It is retrieval augmented generation, right? You basically store the question related documents in a vector database and then retrieve them to provide context to your model. That's the first 3 parts. And then you have an evaluation setup. Basically, the evaluation itself is a core part of our course, but then just kind of giving you a very high level overview is you collect a well distributed sample of queries, expected answers, and then you also design a framework where you have different kinds of use cases, basically unit test cases, regression test cases, semantic test cases, bring in LM judges if required. Again, I'm keeping it very high level just to kind of give you a high level overview, but then all of this is a part of building the system. And then you build and run the system, and you basically implement monitoring and logging as well to see your retrieval latency, how many tokens are being used, projected costs, and all of this, right? These are super important when you're deploying AI systems. Now, fine, now we have this 5-step process. We're kind of at our solution. Now, this is when you start thinking, what is the optimization I need to be doing, right? Let's say your retrieval is too slow, you're getting documents too slowly. Then there are techniques like adaptive RAG, where you dynamically choose between doing RAG versus using the LLM to answer a solution. You can implement something that's called semantic caching, where you cache frequently asked questions to reduce redundant calls. Then let's say your documents are not retrieved well. You're asking a question, but the right documents are not coming up to answer that question. Then we use a technique called hide, where you reformulate these queries for better retrieval. You can also optimize the chunking strategy that you have. Again, if all of these are feeling like too much of information, just stay with us. These are techniques that are generally used, and if you don't understand them very deeply, it's fine. Focus on the problem. And let's say your system is hallucinating very often, right? Then there are techniques like self-RAG or corrective RAG, where the LLM verifies its own response before actually generating it. Otherwise, let's add new personalization features, right? Then you can probably add a layer of personalization, and let's say you want to optimize for multi-document queries, like questions where you're picking up documents from picking up context from different documents. Then you have something called hybrid retrieval. Let's say you want your employees to be asking questions from videos or images, then you implement multimodal RAG. Then let's say when you want to go for personalized employee queries, you have something like prompt chaining, where you could chain multiple prompts in order to lead it to a workflow, or you could implement a routing LLM. And even for complex decision making, which your problem will kind of guide, you can also consider agentic RAG and things like that, right? If you kind of see, we actually went through 10 different state-of-the-art AI strategies as targeted solutions to different problems in our AI system design, right? Not as isolated concepts. Now, this is kind of the essence of what we're trying to get at, which is let your problem define your design and not your isolated concepts. Now, because this space is growing so quickly, all of us know 100 different things. We're reading that, oh, there is this new RAG concept, there's this new agentic concept, but we don't really understand where to use them. Now, this is basically the essence of our course, that all through the process, we'll be picking up problems and telling you or equipping you with the right kind of tools or resources so that you can solve it, as opposed to just telling you that there are 100 types of RAG, there are 20 different ways you can implement agents and all of that, so that you as a person in the enterprise can go like, okay, if this is the problem, this is how I'm going to solve it step by step. And these are all the tools that I have in order to solve problems, right? The essence is basically that AI research, anything I have been reading papers for about 9 or 10 years now. And if there's one line to summarize which of these research is useful, it's basically that this research or any new tools become far more intuitive when applied as problem solving mechanisms rather than standalone techniques, right? And that's pretty much what we're trying to teach with our course. We will be covering all of these concepts. Basically, think of our course as an extended version of whatever we went over. How do you design these solutions? How do you choose the right approaches? But kind of giving you a very problem first lens to it. We'll also be going over how to build Perplexity from scratch. Today, if I asked, there's one very clear way to say how many people really know GenAI well, because if I throw a problem at them, like let's say you want to build ChatGPT today, how would you build it? The really smart people are the ones who are asking the right questions, who are targeting the right problems. So we'll also be building something like Perplexity, your own AI search system, step by step, where we'll be implementing all of these state-of-the-art techniques, right? So we have 1 minute left, and we did cover pretty much in time. So we'll probably stay back for questions and any kind of concerns you have or anything to do with the course. Also, thank you so much for attending.
Yeah, I'll take on a couple of questions that we are currently seeing in the chat in terms of if you join this meeting late, can I get the recording? Yes, we will post the recording on the course page soon. And the second question was how much coding is required for this course? So while coding is required basically for you to actually build a working product, that's not the emphasis of the course. The emphasis is to actually understand how do you apply these concepts, how do you match which problem can be solved by which of these components that Aishwarya talked about. And that's the main focus. So there is coding, but I mean, these days you can get a lot of help to actually write code from LLMs.
And just a heads up that we have low code options, drag and drop options available, but I'm not one of those people who says don't learn coding at all. We'll make it so easy for you to pick it up, so don't worry about it. But very basic Python experience is required.
Aishwarya, do you want to take a couple of questions?
What level of prerequisites is needed for this course? Again, like I said, Python programming is required. The ideal students for this course would be software engineers, data scientists, ML scientists, product managers, leaders who are kind of, if you're managing a team of, people building AI products, if you're an entrepreneur, because this is the right time to build, and so many people build in the wrong direction. So I feel like even if you're an entrepreneur who's trying to build in this area, it would be super important to look at this space at a very problem first perspective. It is pretty much open to anybody who wants to start designing solutions with generative AI. We want this to be a low entry bar kind of a course, but we want you to leave with a bunch of frameworks that will help you, keep good pace with this space, regardless of how fast it's moving, right? Because we feel like we've gotten all of this experience from really working on these problems and not really. Uh, or TLDR is, if you read a bunch of basic textbooks and content on the internet, I feel like it's very hard to gain this expertise because you don't really understand what are the real problems you're going to see and how is the research being useful. And we want to kind of impart all of that knowledge to you. So basically, if you want to get into the space and start building enterprise ready problems, this is the foundational one-on-one course for you.